Good morning.
Good morning.
I just have no stable from checking.
All right, let's see. Who's out in Holbrook? Looks like we've got a couple of...
Tara.
Who?
Tara.
All right, and then we have Jill and Avery and...
They're here. Our bell is about 2 minutes later than when the actual thing starts. It's kind of weird. I think our clocks are all off.
Okay.
Yeah.
All right. Well, okay. All right. Well, today what we're going to do is we're going to cover section 3.3. And let me pop that up. Other common functions or parent graphs. This is actually the last section that will be on the midterm. The midterm will cover section 1.1 through 3.3. Okay, so we'll be finishing that up. Okay. All right. Other things that so I guess tomorrow we are going to have a Moodle Day. All right. So what that means is that the quizzes I'm going to open up for you tomorrow. Quizzes 2.5, 2.6, and 3.1. Okay. Then on Wednesday, then I'm going to open up the chapter 2 test for you. Okay. So Moodle Day tomorrow to get those quizzes caught up, and then the chapter 2 test on Wednesday. And so you won't see me until Thursday. Okay. And then we'll either continue on 3.3 or 3.4 or wherever we are. And then at that point, probably on Thursday, once we finish the second test, then I will talk about the midterm. Okay? So we'll just do one step at a time here. So quizzes 2.5, 2.6, 3.1 tomorrow, and then the chapter 2 test on Wednesday. Any questions on our plan for the week? All right. So, okay. Actually, I know, let's see, is Mrs. Smith in there in Holbrook?
Yeah.
Okay, so Mrs. Smith is, I think last week when we talked about this, I know Miss Buckley was there. Is that going to work for you if we have a Moodle Day tomorrow and just have them work on the computers?
Yeah, that'll be fine.
Okay, all right, great, thank you. Okay, so yeah, it turns out, remember I said we were going to either do it Tuesday or Thursday, and it turns out the afternoon class wanted Tuesday as well, so it worked out good for everyone. All right, so any other questions, comments, concerns before we get started here for today? All right, well, let's do it. All right, well, so today, you'll be excited to learn that I'm going to teach you some dance moves. So, unfortunately, I know you guys have all had your homecoming dances already, but, maybe winter formal, more, Sadie Hawkins, whatever, at least by prom. Anyway, so I'm going to teach you some dance moves today, so that should be kind of fun. But you might only want to do it when you're dancing with someone else that's at my class, but anyway, we'll see. Okay, so here we go. So this is called other common functions. I call it parent graphs because we're going to be talking about some of the basic graphs, And so if you learn the basic looks of them, then you can graph it just in seconds instead of even instead of a minute, putting it in your calculator. You can just graph it by hand for most of what we're going to be doing. So we're going to talk about polynomial functions, rational functions, radical functions, and then absolute value, greatest integer, and piecewise functions. Those are the different types that we're going to do. All right? So we're going to start off with functions of the form ax to the n. So these are polynomial functions. Okay? So when we talk about whether it's even or odd, what we really mean is the exponent even or odd here. And if the exponent is odd, then the graph goes like the cubic function. And so the cubic function goes up from left to right. This is the graph of the cubic function. But it goes down from left to right if it's negative. Now, what we mean by if it's negative is if the coefficient is negative. So if I say odd negative, the odd is from the exponent, the negative is from the coefficient. So if I say odd positive, the odd is from the exponent, positive is if the coefficient is positive. Okay? So those are that's the basic look of those two graphs. Is you look at, so if the exponent is odd and it's a polynomial, then it'll either go up from left to right or down. Okay? So the idea is this, is that once you recognize, hey, there's a polynomial function, odd, negative, then you don't have to put it in your calculator. All I want is a basic look. It'll go down from left to right. I want it to cross in the origin at the origin, and then just keep on going down. So it goes down, flattens out a little bit, and then goes down. You don't have to draw it any more exact than that. Okay? So what we're talking about is just doing a really rough sketch. All right? So now I want you to do practice 1A on your paper. All right, so draw it for me in the air. What does it look like? All right, good. So if it's odd, negative, then it starts up to the left and then it's going to go down. Okay? And it passes through the origin. So that's about as good as we want right there. Doesn't have to be more exact. All right, any questions on that? All right, so if n is even, the graph goes like a parabola where both sides of it are together, either up or down. So like y equals x squared, if the coefficient is positive, it has the U shape, it goes up. If it's negative, both ends go down. All right. So then this is kind of the function dance is what I call it. Okay, this is not in your book. I just made this up. Okay. So the function dance moves go like this. Is if you say even positive, then it's both ends up. So you put your hands in the air, like you just don't care. Oh, that's something else. Yeah. And okay, so that's even positive. Okay, even negative, you put your hands down. Okay, all right. And then odd positive, you put your right hand up and your left hand down. And then odd negative, You can go like that, and you put a little hip into it if you want, shake your booty, whatever. Okay, so that's the function, the different moves of the function dance. There you go. So now let me just, before we do any more with that, let me just say that this does what we call the end behavior, or the behavior at the ends of your graph. Okay, it doesn't tell you what's going on here in the middle. All you know is that the ends of it go up. Okay, all right, so let's just practice a little bit. All right, so I would like everyone to stand up. Everybody stand up. All right, there you go, Avery, you got it. Okay, all right, so I'm going to call it out a little bit, and then we'll see if you can keep up. Okay, so even positive, even negative, odd positive. Okay, it's with like this, the right arm up. Okay, and odd negative. So with the left arm up. Okay, all right, so odd positive. Okay, and even negative, even positive. All right, so just stay standing, stay standing. Okay, so now we are going to get Hannah. Okay, so Hannah, you're going to be our caller. So you call out the moves that you want everybody to do, and then see if they can keep up. Now, if you get one wrong, you got to sit down, and we'll just see who can last the longest. All right, so go ahead, Hannah.
Odd negative.
Okay, so odd negative. If you didn't do this, you need to sit down.
Wait. Can you?
Right? All right, keep going.
Even positive.
What?
Even positive.
Okay, even positive. Okay, all right, in the back. Yeah, you guys, that's right. You didn't do this. All right, keep going.
Odd negative.
Odd negative. Okay, Avery, you're out. Lauren, you're out. Okay. All right, let's do one more. Weren't you still in? Taylor? Weren't you still in? Yeah. Or I guess you won. Was she the only one? Was there no one left in Holbrook? No? All right. So Taylor, you win. Okay, good job. Okay, you're the dance queen. Okay, so when we do round 2, see, those are only half the moves. When we do round 2, then we'll let you start off with for us. So, all right, let's go back to the notes. Okay, so if we're going to graph x to the 6th, then you say, okay, this is even positive, so both ends up, and so you just graph it like that. So just see, it just takes seconds to do. Okay, all right, now, so go ahead and do practice 1B. Okay, draw it for me in the air. Okay, or do the dance move. Yeah, see, the dividing by 5, that doesn't even really affect it too much. For what we're doing today, okay, it's going to be both ends up, and then it is going to cross here at the origin. What the 1/5 does, you might remember when we did parabolas, when you had a number in front, it made it wider if the number was bigger than 1. So, but we're not worried about that just really today. Okay. Okay, next, the functions of the form a divided by x to the n. Okay, so these are not polynomial functions. You might actually want to write next to that, the word rational. Okay? So these are rational functions. So a divided by x to the n, or that's the same thing as ax to the minus n. So the variable is in the denominator. Okay? Now, in these, we have a vertical asymptote. And so what we're talking about with the graphs is what's happening on either side of the vertical asymptote. So if n is odd, the graph goes in opposite directions on each side of the vertical asymptote. Okay? So most of these have a vertical asymptote. So instead of doing the end behavior on these, what we're doing is the behavior on each side of the vertical asymptote. Okay? So instead of your arms being out, you bring them in for the function dance. But the moves are actually the same. So if it's even positive, then the graph goes like this on either side of the vertical asymptote. Even negative, odd positive, okay, with the left, let's see, odd positive and odd negative, okay? All right, so, okay, so then let's do the, so if I just say even positive, then that means, you assume that means polynomials. But if I say rational even positive, then that's going to be coming in like this. Okay, because now we're talking about on both sides of the vertical asymptote. Okay, so even positive, even negative, odd positive, odd negative. Okay, so when we're doing the graph, what I'm looking at is what happens on either side of the vertical asymptote. And so if this is a rational function and it's odd positive, then if you're going to go up to the right of the vertical asymptote, down to the left. Okay? So this is our dance move. So if it's a polynomial, odd positive, it's like this. If it's rational, you bring your arms in because it's on the vertical asymptote. Okay? All right, so go ahead and try practice 2A, please. All right, so what would that look like? Show me the dance move for that one. It's rational, odd, negative. So it's up to the left, down with the right. Okay, here let's switch over. Okay, so up with the left side, down with the right side. Okay. All right, and so then if it's if you have rational, even, then the graph goes the same direction on both sides of the vertical asymptote. Okay? So when the coefficient is positive, both ends go up on either side of the vertical asymptote. If it's negative, if the coefficient is negative, both ends go down. All right, so in this one, so you say rational, even, negative, both bring your arms together, both ends down. And so then this would be on each side of the vertical asymptote. Okay? All right, so go ahead and do practice 2B. Whoops. All right, so show me the graph in the air for that one. Okay, good. So both ends down. Okay. Any questions? All right, so stand
Yes.
up.
Yes,
Oh.
I have a question.
Go ahead, please.
How do you do that? I'm not seeing what you're doing there. I don't get it.
Okay, so you say first of all it's a rational because the x is in the denominator, so it's a rational. Second, the exponent is even, and then third it's negative, the negative coefficient. Okay, so if it's rational, you bring your arms together, you bring your hands together, and then if it's even, positive, they're both up, even, negative, they're both down. So when you do the graph, so you know that both ends are going down on either side of the vertical asymptote. Okay? So that's all I'm wanting out of this.
Okay, I got it. Thanks.
Okay? So let's, so everybody stand up. Let's do a little more practice here. Okay, so if I just say even positive, then that means it's assumed to be a polynomial. But if I say a rational even positive, then you bring your arms in. Okay? All right, so here we go. Rational even negative. Odd positive. Okay? Okay, so on odd positive, it's your right arm that's up. Okay? All right, rational odd positive. Okay? All right, so rational together, odd positive means you have your right arm up, your left arm down. Okay? All right, so Taylor, why don't you call it out? Call out a few of them, and let's see how long people can last.
Okay. Even negative.
No, Avery.
Okay, Avery, you're out. If both ends down. Okay.
Okay.
It's okay, Avery.
Rational even positive.
Okay, good.
Okay. Odd negative.
No.
Okay, all of you that don't have your left arm up, your right arm down. So most of Holbrook is out.
No, I'm not.
You were right.
Left. No, I didn't.
Left arm's up. She's right.
You switch.
Rational even negative.
Okay, like this. All right, keep going. We've got two left in Holbrook, and
Odd negative.
okay. Let's see. I think in Holbrook is that Anna? Did you do the wrong one? The wrong one first? No. Okay. All right. Keep going.
Okay. Rational odd positive.
Okay.
Odd negative.
Okay. All right. Go
Um,
faster. Go faster.
Even negative. Odd negative. Odd positive. Rational even positive.
All right, we're out in Holbrook. Okay, I think Lauren got it. So, all right, good job. Give her a hand. Okay. All right, we got our two dance queens going on. All right, so anyway, so yeah, you can get into it when you're on the dance floor. You can do some of this and whatever. Okay, but no, you guys did a great job with that. That was fun. Okay, so now we're going to talk about the next type, which are the radical expressions. Okay? All right, now, so with these, I guess the dance moves are like, let's see, I don't know if you guys know disco moves, but like the disco move, when you start down and you point like that, there was a lot of pointing in the disco days. Okay, so like you start down. It's almost like drawing a sword out, but you point to the opposite direction. Okay, that's what the different roots look like. So if it says if n is odd, the graph goes like the cube root of x, or x to the 1/3. Okay, now so the cubed root, it's kind of like this, except it does go on infinitely in each direction. And that's kind of important. And so it's almost like if you could have like this side going down low and this side going down high. Okay? And then if it's negative, you go in the opposite direction. This side's going high and this side's going low. Okay? But x cubed, this is x cubed. The cube root of x, this is one that if you could memorize, it will really help you. Because then all of the odd positives look like that. Whereas the odd negatives go in the opposite direction. Okay? All right. So here you say, okay, this is a radical. Because when you have x to a fractional exponent, that's the same thing as the 7th root of x. Okay? And then it's negative. So then it's going to go up and down this way. And then if it's positive, it goes like this. Okay? All right. So go ahead and try practice 3A. See if you can figure out which way it's supposed to go. All right, so the way we would say this is, instead of rational, this is a radical. Okay, it says it's like a square root, cubed root. So this is a radical, and the index is odd, and then it's not negative, so it's positive. So radical, odd, positive. All right, so show me the move for that. Radical, odd, positive. Good. So, all right. So it goes up to the right and down to the left. Okay? All right? Now, if n is even, the graph goes like the square root graph. Okay? So the square root or 1/2. See, if n is even, you can't have a negative. Because you can't have a negative square root. We're not dealing with complex numbers here. So anytime the index is even, then it's just going to be one arm. Okay? So you'll only use one arm on this one. So if it's positive, it goes up to the right. If it's negative, it goes up to the left. But you only use one arm on this move. Okay? All right? So you say, okay, so this is a radical, even, positive, so it goes up to the right with just one arm. Okay? All right, so do practice 3B. All right, so show me in the air what that one looks like. So isn't that the same as this one? Yeah, pretty much. I mean, if you're graphing with your arms, it looks the same. Now, on the calculator, you can see that one is a little flatter than the other, but we're not worrying about that. We're just worried about the basic looks. So if you do radical, even, positive, then we're just using one arm going up to the right. And if it's negative, we use one arm to the left. Okay? All right. So like that. All right, next, the absolute value function. Now, the absolute value function, in calculus, it's often good to think about this as actually two lines that come together. Now, usually in algebra, we don't think of it like that, but in calculus, it helps us to get rid of the absolute value symbol. And so this you could actually think of as a piecewise function where it's in two parts. So when x is positive or 0, then you get the positive part of the v, the right side. When x is negative, you get negative x, which is the other side of the v. Okay? So while we do a parabola like this, for the absolute value, try to make it more v-shaped. Okay? I mean, you could come like this, but make it more v, whereas the parabola is more U-shaped. Okay? So, if I put a 3 in front, then any number bigger than 1 is going to just make the V shape more narrow. Okay? The bigger the number, the narrower you get. If you have a number in front that's between 0 and 1, then it will be wider. Okay? Then, just like with the parabola, if you have a negative, the negative causes it to go down. Okay? But again, then you figure out if it's a wider V or if it's narrow V going down. Okay? All right, so go ahead and try practice 4, please. All right, so graph it in the air for me. Or show me with your arms. Okay, so it's going to go down, and it's a little bit narrower V. Okay. All right, any questions on that? Now, the thing that I like about this section is with a little practice, it makes a lot of the graphing either you can get it pretty accurately in your head in just a couple of seconds, or if you get confused and let's say you can't remember, okay, you can always put in your calculator on a test or a quiz and just double check. And so that's kind of nice. All right. So it kind of takes some of the pressure off. All right. Okay, next, the greatest integer function. Because of the vertical jumps, the greatest integer function is an example of a step function. Now, a lot of times you might see it written with like two sets of brackets, or you might see one set that's bold, okay? On the Moodle, it's kind of hard to see the bold, but from context, just know that if you see the brackets, it's going to be greatest integer. Now, on your calculator, it's INTX, the greatest integer. And if you remember, we talked about the greatest integer function before, and it's the last, if as you're going from left to right, it's the last integer you pass. So like the greatest integer 1.7, well, the last integer we pass from left to right is 1. All right? But if I do the greatest integer in negative 1.9, see, the last integer we would have passed from left to right would be negative 2. Okay? Now, when we go to graph these, okay, so to graph the greatest integer function, to get that int, you do math number 5. So let me go through that really quick just to remind you what we did in chapter 1 with this greatest integer function. Okay. So you do y equals to graph it. And so then it's the math key. Then you arrow over to number. And then option 5 is int, x. So math number 5. And then, so int, if you type in x now, then that's the greatest integer in x. And so when you graph that, then that's your little step function. Okay? Because every number, for example, between 0 and 1, the greatest integer is 0. And then when you hit 1, then it pops up 1. And so that's why it looks like a staircase. Now, I want you to kind of notice this. Okay? This is not, you're not going to see this on your paper. You need to look up here on your screen, on the screen. Is that this is an open dot, and we're here, a closed dot. When you get to 1, see, the greatest integer in 1 is going to jump you up to the next line. The greatest integer in 1.1 is 1, 1.2 is 1, 1.5, 1.9. But then when you hit 2, the greatest integer in 2, it jumps you up to the next step. Okay? So it's important when you graph these on the paper to know that the right side is going to be an open dot. Because if you had 2 closed dots here, it wouldn't pass the vertical line test. So you have to have 1 open and 1 closed. And see, you're not going to get that on your calculator either. Is that part you need to know, and you need to add that to your graphs. Okay? All right. So go ahead and do practice 5. So it says graph that function. So I'm testing to see if you can put in your calculator right. And then evaluate the function when x is negative 1, 2, and 3/2.
Mr. Strong, where
Yes.
is the math button on the calculator?
Okay, it's on the first column,
Oh,
the third one down.
okay, thanks.
You're welcome. All right, so first of all, does anyone have any trouble getting the graph to show? Okay, so go to your y equals, all right, and clear out if there's anything else there. and then press math number 5, and it should show int open parentheses. Okay, so then you press X and close parentheses plus 1. And so your graph, so it'll look like this. Let's see. So y1 equals int x plus 1. That's what it'll look like on your y equals screen. Okay, and this is the graph that I want. Now, if you're using older calculators, then sometimes they'll actually show these vertical lines connecting the steps, but that's wrong. It actually doesn't have the vertical lines. Okay. So this is the graph that I'm looking for. All right, so Caitlin, what is the value, what is the f of -1? What's the greatest integer in -1 plus 1?
Is it 0 or is it 1?
It's neither one of those. Oh wait. No, it would be 0. You had it right the first time. So the greatest integer in -1 is -1 plus 1 would be 0. Okay? All right, Sierra, what is the f of 2?
Is it 1?
No, because the greatest integer in 2, see, that's right on the number line. So that integer value, the greatest integer in 2 is just 2. The greatest integer in 2.1 is 2. The greatest integer in 2.5 is 2. The greatest integer in 2.9 is 2.
2.1.
So the greatest integer in 2 is 2, plus 1 would be 3. So the answer is 3. All right? Now, what's the... All right, so Madison, what's the f of 3/2?
One.
Okay, so the greatest integer in 3/2 is 1, but then you add 1 to it, so your final answer is
2.
2. Okay. Now, let me show you a little trick here. All right, so here we wanted the greatest integer in x plus 1. So if you ever have to evaluate a function like I'm asking you to do for these 3 numbers, let me show you a cool little shortcut. Is if you press trace, and then see it has x equals 0, y equals 1. So, but if you want to change it to x equals -1, just type -1, and see, then it not only tells you the answer to the problem, but it also shows you where it is on the graph. Okay? Or if I wanted to go plug in 2, so I plug in 2, press enter, and so then it shows me the answer is 3, and shows me where that is on the graph. And then finally, 3/2, 3 divided by 2, press enter, and so then it shows me the answer is 2. So that's kind of a cool little trick. When you have the graph and you're in trace mode, then all you need, once you press trace, you just type in whatever x value and it'll tell you what y value it is. Okay? All right. So the last type of function here is the piecewise defined functions. It says to sketch the graph of a piecewise defined function, graph one part at a time. Now, I've got two little hints here down below. Number one, watch the domain. And number two, remember the vertical line test. See, what happens on these is people will graph each part and not remember the domain, watch the domain, or remember the vertical line test. So they'll end up with a graph like this. Well, remember, these are functions. They're in pieces, but they're supposed to be functions. So your final answer, see, this cannot be right because a vertical line hits your answer more than once. So that means it's not a function. So that cannot be right. Okay? So when I say watch the domain, you're going to have to erase part of the graph so that your graph passes the vertical line test. Okay? So let me give you an example. All right. So let's say I want to graph f of x equals negative x plus 3 for x is less than 0 and x squared for x is greater than or equal to 0. Okay? So you start off graphing the line. So this is like y equals negative x plus 3. So you go up to 3, and then your slope is negative 1, down 1 over 1, down 1 over 1. And so you get this line right here. But now you got to look at the domain. The domain says we only want the part of that graph where x is less than 0. So we only want this negative part. So this positive part, you get rid of that. So erase it or whatever. You're going to get rid of that part of the graph because you only want this part where the x values are to the left of 0. All right, similarly, you do the black part. Y equals x squared. Well, that would be this entire parabola right here. Y equals x squared. But, see, you only want the part of the graph where x is greater than or equal to 0. So you don't want the whole parabola, you just want the positive half. So you erase that negative part. And so this is the part you do. Now, this or equal to means it's that when x is equal to 0, it's on this graph, not this. So you make this a solid dot, this an open dot. Okay, then when you're finished with your graph, you think of the vertical line test and imagine a vertical line going through your graph. Does it ever hit anywhere more than once? And the answer is no, so that's good. All right, so go ahead and try practice 6. All right, so I see most of you have your pens up. So just check your work with this graph. Okay, so when x is less than 0, we get the left half of the parabola, an open circle here. When x is greater than or equal to 0, we get y equals x minus 1, which would be this line right here, but only the positive half of it. And make sure that you don't have anything like this where there's any like overlap. The graphs cannot overlap and have it be a function, because remember, it has to pass the vertical line test. All right, so any questions on that? So any questions on 3.3? All right, well, I don't think I'm going to start on 3.4. So let me just kind of go over just a couple of important ideas here really quick before we're done here for the day. Okay, so tomorrow I'm going to unlock quizzes 2.5, 2.6, and 3.1 for our Moodle day. On Wednesday, you're going to take the Chapter 2 test. Okay, so that's coming up. The other thing you might want to write down in your calendar is the last day of class. Somebody was asking me about that. The last day of class is December 16th. So that will be the last day of our final. So can I assume that you guys are in class till the 20th? Is that about right? For your high schools? Okay. So that week, and actually the first couple of weeks in December, again, you'll have your class or whatever, but we won't meet. So you'll finish your final on the 16th. I'll probably grade everything on the 17th, and then I'll turn in your grades on the 18th, so that before you leave for Christmas break, and you'll know your exact overall average and everything. Okay, but the 16th will be the last day of our final exam. Okay. All right. Any other questions?
Our final covers to which chapter then?
Our final will be comprehensive. It'll cover everything, with an emphasis on the second half.
That's what I mean. Like, what chapter does it go to? Because the midterm is to 3, chapter 3 and book 4.
The total. It's 1 through 5 and 10. 1 through 5 and 10. And it talks about all that in the syllabus as well. All right, well, we're out of time. So you guys, good luck on your tests, on your quizzes, and let me know if there's a problem. Otherwise, I will see you on Thursday. Hope you have a great day. See ya.
Joseph City, a reminder, we want those 3 quizzes opened during 6th hour today. So
Are those supposed to be open?
Wait, is that for the juniors?
Yeah.
Oh, okay. I think I already took care of that. Okay.
Okay.
I was
Thank you.
panicking there for just a second. So
No, it's already scheduled to be open though. You've already got it lined out.
Yeah.
Okay.
Yeah, if they go to their Moodle, you should see it already.